Okay, ladies and gentlemen, hopefully you are seeing me all fine, and later on, more than my face, I want you to see all the diagrams. Before I go into any further, welcome to udroneanywhere.com Drone Technology course, Module 1, Aerodynamics. As a start, I would go through some of the figures that I have listed out, pretty much giving you a breakdown of how we plan to go ahead with the course. And I would like to be without papers, but unfortunately we still have to deal with some papers. In fact, trying to get into the subject, first of all, I would like to let you know two main factors. To start with, I'm going to say something like kindly. Do not sue me or take me to courts. Have you heard of the saying that if you ask a bank robber, why did you rob a bank, and you get an answer, oh, that's where the money is? Yes, this is a bad example, but why I'm saying this is aviation would be where the money is, the way that drones develop by the minute. And having said that, have you I know, I'm glad that you are my students and not my wife, because she's going to tell me, look, rather than going in a tangent, why don't I get into the subject? But this is very important. In the drone technology course, module 1 is aerodynamics, but on module 8, what we teach people is to get the remote pilot license from FAA. FAA is offering the license for $150. If you don't get the pilot license for $150, so we are silly, right? So, and then I would like to ask you the question, have you observed the persona that is being carried by commercial pilots? I'm not really talking about the prestige part of it, but the high level of ethics that they present as a commercial pilot, and accountability and discipline and all those sorts of good habits. When you get the remote license, you are also getting a part of it. Now, let me list out these modules that on the module, the figures that we have. Figure 1 would be a text of this audio that I am presenting to you. Figure 2 would be a list of figures on module 1, like I am reading out to you. And figure 3, you will get a link of all the links that we recommend. And figure 4, let's start on this airplane parts and functions. You can call it gadgets and or services of an aircraft. This is a NASA diagram. So all the compliments and thanks to NASA. I'm going to bring this up. And let's see what's going on over here on this NASA figure. Let's get a little closer to this one. And also what I would like to tell you at this point is, even if you don't see the figures very well, you can go into our website. We have much better resolution figures, even like in case, even if that doesn't happen, you can get into our chat program and talk to us. We are not perfect. We will get back to you. We'll chat with you and correct the situation. And speaking of which, if you can see this, let's see, is on this plane figure, you see all a complete plane, fixed wing airplane, and as parts you have all these marked. Out of that, I would like to pay your attention to the what you have on the wings itself. You got the ailerons right at the back, changing the rolling of the plane, back and forth, and then you got the flaps as a secondary control thing. Where I would want to distinguish between the primary controls of a fixed wing aircraft and a secondary control of fixed wing aircraft as we go on to explain. And the ailerons, it shows you changed roll, and elevator right over here, changing the pitch, that means climbing and descending. And of course rudder, changing the yaw, that means on the vertical axis it would be changing the position. And then winglets, in fact we will be talking on the winglets on a little bit of a lengthy way when we discuss the wing effects and how the plane takes to the air, what makes it get airborne. We will be discussing in length. And of course you see the wing and engine, main things as controlled gadgets or control services of a plane. What we would be discussing would be the ailerons, flaps, rudder, elevator, and vertical stabilizer, horizontal stabilizer. Those are would be things that we would be going through. And what we are trying to do here is give you the fundamentals of aerodynamics. That means teach you on fixed wing aircraft how an airplane flies, and then we will move into the second stage in a brief way, the helicopters, that means a rotary wing, and then on to drones. The good thing about it is usually when we grow, if you go from stage 1, stage 2 to stage 3, it becomes more complicated. But thankfully on drones, at least when we come to drones, the third level, it becomes easier. Fascinating, right? Okay, let me show you the first figure that we would be more concentrating at this point. The understanding of how a plane takes to the air. We want to discuss it in this way to simplify and understand the airfoil. As we see in this famous diagram, once again, NASA picture, or it's all over the place. Even if you go to Wikipedia, you would see that. See, the shape of the wing is mainly is the fact that it takes a fixed wing aircraft takes to the air. So if you look at as you see over here, the relative air, we will discuss what exactly relative air speed. When the airflow coming this way to the fixed wing aircraft wing, with the low speed is increased pressure, and on the top of the airfoil it is high speed with reduced pressure. In other words, we are talking about pressure difference between underneath the wing of the fixed wing aircraft and over the wing. That makes it, in fact, it gives two methods of two reasons for it to get lifted to the air. One is the shape of it and the pressure difference. So when there is more pressure underneath, it tends the wing to move it, tilt it towards this way, and making it helpful for the lift of the aircraft. And then we are going into another diagram to see the wing as a cross section. So ladies and gentlemen, if you look at it over here, the same cross section of the airfoil or the wing, you would see there are a few markings over here I would like you to remember, because acquiring knowledge of aerodynamics, these names will keep coming up. You got chord line, mean camber line, and camber. So generally, see it, this is marked thickness. You would see upper camber and lower camber. I'm going to show another diagram which describes that. So understanding at least remembering all these identifications is important to understand aerodynamics. Then, before I go any further on the wing aspect, I'm going to bring up at least three elements that we need to discuss understanding basic aerodynamics.